Hello everyone. In this video, we're going to take a look at one example to practice the sampling distribution of the mean and its impact on calculating probabilities. So this example says a plastic company produces cylindrical tubes for various industrial applications. One of their production processes is such that the diameter of a tube is normally distributed with a mean of 1 inch and a standard deviation of 0.02 inch. So to basically summarize what the problem is giving us here is that x, let's call this random variable, is diameter of a tube, and looks like x follows a normal distribution with a mean of 1 and standard deviation of 0.02, so variance is 0.02 squared. Part A says, what is the probability that a single tube has a diameter of more than 1.015 inch? Okay, so a single tube, a diameter of a single tube is x, right? And we want to know what is the probability that x is more than 1.015. So we already know how to calculate that. Let's go ahead and quickly calculate this. So we're calculating probability of x more than 1.015. So what we need to do, because it's normally distributed, we need to change this to standard normal. The first step that I would do is to change this to 1 minus probability of x less than 1.015, because later we need to use the normal distribution table and to calculate this probability, and that is a cumulative distribution, so you would have to have a probability in terms of CDF. So 1 minus probability of, now we're changing x to z, which is standard normal, by doing 1.015 minus the mu, which is 1, divided by sigma, standard deviation, which is 0.02. That is equal to 1 minus probability of z less than 0.75. So you need to read this from the normal distribution table or calculate it in Excel, and you would get 0.23. So it looks like 23% chance is for the diameter to be more than 1.015. So essentially, if you think about the distribution of this diameter of tubes, it has this average of 1, and standard deviation is 0.02, so 3 standard deviation to the right and left limit is 0.06 and 0.94, right? And 0.015 is essentially, let's say it's here, and what we did here is we calculated this area, and since the entire area, this entire area under the curve is 1, this portion is 0.23, which makes sense. Now, in part B, the problem is asking for what is the probability that the average diameter of 5 tubes is more than 1.015. Average diameter of 5 tubes is essentially an x bar of sample size 5. So we're going to call this x bar 5 because it's the average of 5 tubes. And based on what we discussed earlier, we know that x bar 5 will follow a normal distribution with the same average and standard deviation of or variance of 0.02 squared over 5. So there's a different normal distribution associated with x bar 5 rather than x, right? So what happened here is that this variance now changed to this variance because of the fact that this is an average diameter of 5 tubes. So now we need to calculate probability of x bar 5 greater than 1.015. So let's go ahead and do that. It's the same process. So that will be 1 minus probability of x bar 5 less than 1.015, and we need to change that to z now. So it will be 1 minus probability of z less than 1.015 minus mu, which is 1, over sigma, standard deviation. And standard deviation is this, but square root of that. That's the variance. So 0.02 over square root of n, or in this case, is 5, right? So this is something that you're probably familiar with because a couple of slides back, here's the formula that we were essentially using. X bar 5 minus the mu over sigma 0.02 divided by square root of n, and n is 5 here. So now if you do the math here, is 1 minus probability of z less than 1.67. You need to go to the normal table and read this probability, and once you do the math is 0.047, close to 5% chance. So what happened here from part A to part B? Why the probability went down? Because all we're doing is calculating the probability of x. Now here is x bar greater than the same number. So what happened here is the standard deviation now is changed. Standard deviation has changed from 0.02 to 0.02 divided by square root of 5. So now we have a smaller standard deviation. The distribution of x bar 5 is essentially a little narrower. And what we calculated here is this area for that distribution, right? So that's why the probability went down, because that area is obviously smaller than this area, right, that we calculated in part A. So at this point, you probably can guess what's going to happen in part C, because in part C, what is being asked is what is the probability that the average diameter of 25 tubes is more than that number. So now we're doing probabilities for x bar 25, and that will follow a normal distribution with the same mean in 0.02 squared divided by 25 now. So much smaller standard deviation variability. I'm not going to go through that process, but it's the same process. So essentially what you're doing is probability of x bar 25 now greater than 1.015. And you take the same process, and you will see that this is going to be approximately 0. Because what happens is for x bar 25, now the distribution is much narrower. And that area, maybe I'm just using another color here, this area here is very small for that probability. So that's why it's very close to 0. So as you're increasing your sample size, the probability, the normal distribution gets very narrow with a smaller variance or standard deviation. So that is the impact of sample size. So we're going to look at another example in the next video.